question 5 from the process exam. So I have all of the important information here highlighted. Our necessary mass is 120 kilograms. We need to be able to go up a 10-degree hill that's 1 kilometer long for this speed, and we have to be able to do this 5 times. So for question 1, we're trying to figure out how much power the motor has to produce to be able to meet this design requirement. So I'm going to start by just drawing a quick picture. This is our 1 kilometer here, which is just 1,000 meters. This is our angle, which is 10 degrees. And these are the requirements we must fulfill. I'm going to draw a force diagram. So this is our force of gravity, and this right here is our force of the motor, or the force of traction. That's what's pulling it. And here is our theta. So we know that the power of the motor is going to be equal to the force of the motor, or the force of traction, times the velocity which we have. So the only unknown that we need to figure out is this force of the motor right here. So I'm going to choose to tilt our directional axes so that the motor is parallel with the x, so it's moving in the x direction. And the reason I'm going to do that is just because it makes it a little bit easier to solve. So if this is our gravity, our normal force is going to be up this way, right? Because we're tilted. And so we can draw a triangle here with our mg, and we want to find out the length of this line right here, which is going to be equal to mg sine theta. Or, sorry, my bad. That's going to be this side right here, which is what we want because we're looking for the distances in the x direction. So we want this and this. All right, perfect. So in our x direction, we're going to have our force of the motor minus mg sine theta. And this is going to be equal to our mass times acceleration. Like always, our acceleration is 0 since we have a constant velocity, so we can set that equal to 0, meaning that the force of the motor is equal to mg sine theta, which means that our power is going to be equal to mg sine theta times our velocity, which, let me just move this over and put the velocity in the beginning. So once you put in all of the values that you need for that, you should get that this is equal to around 250 watts of power. For the second part, we need to find how much, or what mass the battery has to be when it can store this much per kilogram. So we need to find the energy needed to do this journey, which is going to be equal to mgh. This is going to be the energy needed to climb the hill. So from this drawing right here, we can figure out our h. Our h is going to be equal to that 1 kilometer times sine of 10. And when you turn that into meters, you're going to get around 174 meters. So we have everything else that we need. We have the mass and we know what gravity is. So we can calculate this energy, and we need to multiply this by 5. The reason for that is because we need to be able to climb this hill 5 times before the battery runs out. So it's going to be 5 mgh, and h is equal to the distance times sine of theta. This altogether should equal around 1,042 kilojoules. Remember, when you plug this straight up into your calculator, you'll get it in joules, and you need to convert to kilojoules. And the reason you need to is because this is given in kilojoules right here. So we're just going to divide these out. So we get 142 kilojoules divided by our 800 kilojoules per kilometer, by kilogram. These are going to cancel, and we'll be left with our answer in kilograms, and it should be around 1.3 kilograms that the battery needs to weigh in order to fulfill these requirements.